All right, so the recording has begun. This is our Sunday session, the Mother's Day special, they say. And so we're here doing some bio. I'm gonna share my screen. Um, so Nancy, you come late, so we have to start. Hopefully you join us
We supposed to have an next bio.
Sunday next week Sunday. Until
No, I mean like a student.
no, just you and Nancy.
Okay. Cooper gotta come too.
No,
Help.
all I'm gonna come. They it's interesting. If it ain't specifically BJC, it's like, you know,
Yeah, they ain't there yet.
no, no. Paper three. Okay, let's begin. This is paper three, 2000 13, and this exam was in May. This exam was in May. Um, so what they say here? Answer all questions in section A, 1 through 4, and then answer 2 out of the 3 questions in section B. So you have a choice for section 2. You have a choice for section B, but for section A, you don't have a choice. Can you see my screen, by the way?
Yeah.
Okay, that's good. All right, so let's dive in. So these ones are the mandatory ones. Section A. What is 2013? 2013. Oh, and 2011. All right, see what's happening. Give me one moment. But like one thing I noticed with these things, they be the same things over and over and over again. So once you get the concept, once you get the idea, ain't none they could throw at you that you wouldn't
Yeah.
get. You know what I mean? That's what I mean like with it. Once you cover the topic thoroughly, they usually stay within the basics. Usually stay within the basics. So that's a good thing. And a bad thing at the same time. You know.
I mean, it's not really a bad thing because you have to know the information to benefit from it. You know.
I say bad thing. I mean, you know, sometimes we need some stuff to scratch us so that we could push ourselves higher. Um, okay, so let's go. This one says the graph shows the effect of pH on the rate of enzymes. So I have two enzymes, A and B. So we have the rate of activity and we have enzyme A and enzyme B. It says describe, sorry, you can see my screen, right?
Yeah.
It says describe the effect of pH on enzyme B. Okay. Describe the effect of pH on enzyme B. So how would you answer this question?
Well, I could say that the higher the pH level, the at lower pH levels, the enzyme works,
At lower
and
peak,
as
at lower pH level, what do you mean?
pH,
pH, say pH, okay.
yeah, and at
Say that
pH
again.
level,
Read it again. At what?
like from pH level 7 to what that is, 7, 8, 9, 10, like 7 to 10, it works, but after it gets denatured from 10 and above.
10 and above.
That's,
Okay. Yeah, you basically on the right track. So um we'd say from we'd say as the pH level increases, enzyme activity also increases, right? Until
yeah,
until we have a maximum rate of activity. After that maximum rate of activity, um, we have um, we have that if you add more, if you increase the pH, um, then um, the enzyme activity actually lowers, right? But we could play with the numbers. The optimum pH of B is what? Let's see if we could
But
slice it
that's
up.
like the middle of 7 and 14.
The best thing to do with this graph, in my opinion, if I had to do it, is I would try to slice it up in even pieces and then see how that works. So
Yeah, around 10.5 pH.
yeah, 10.5. It looks like 10.5, but let's see.
Yeah, just take the median.
You take the mean of the two,
Yeah,
but is that the middle? Though not exactly the middle. Would you agree? Not exactly the middle of them. Guess who's
so you
correct?
think the range would be better than.
No, I would think I would separate it into even parts. One moment. Go ahead, Nancy. I'm joining you on right now. So sorry about that. I just got in. Okay, no problem. So I'm joining the class. Yeah, come right in. Come right in. We ready? Start. Oh wow. Yeah. Alright, I'm coming in now. I'm so sorry about that. No problem. Yep. As you were saying, right?
Yeah,
But at least she come in, so that's a good thing. Okay, so what I'd say is I wouldn't taking the range wouldn't be helpful there. What you want to do is you want to divide this thing evenly, and so trying to figure out if I actually had a ruler, I'd figure out the length of this. In fact, let me get a ruler and then figure out the actual length. So I should have done long time, you know. So ruler image. If we get a ruler and put it against it, see how much we have incrementally. So copy that. It's in millimeters. So millimeters would be great for us. That way we could easily um, figure out it. Perfect. You see that? But that works so good. My. Perfect. Just slide that on right there. Good. We could count now. You understand what I'm saying?
yeah. Just use the
Just use the
ruler to be
yeah
exact.
to be exact. So if this is 7, but the thing is though, we have to find. Okay, so let me see something. We have to actually okay to see the actual distance. What we notice is that let me go from 7 to 1. That's 1 centimeter. So that's that. We actually range from 0 to about 8. Not quite though, but it's more 8.1. It's more like 8.1 if we be sure if we be careful. Let me zoom in. What's 8? Um let's move it over. See if we get anything. Yeah, still more 8.1 than anything. So if we be intruder it, we'd say that's 8.1. So 8.1 plus 8.1 we basically are calling okay. Hello. Okay, so that's 8.1.
Hi,
Hey Nancy, how you doing?
I'm good-ish.
Yeah, we happy to see you. We happy to have you. Right
I'm
in the
so sorry.
right
So
in the
sorry about.
pineapple.
Good day, Nancy. Welcome.
I didn't miss much, eh?
This is our first question.
No,
So
no, honestly.
Okay.
yeah. So let me bring up the speed before we actually continue with this. To let you know what we're trying to do. So we are on, but actually good to see you though. But I was like, where is she? She probably coming like 2:30, 3:30. um,
It took me long to walk. I'm so sorry.
okay, that's fine.
Sorry.
Um, paper three. This is 2013. Um, and the first question that we look at, it says the graph shows the effect of pH on the rate of two enzymes A and B. And the first question says describe the effect of pH on enzyme B. And so what I told Bethel is that the way how we're gonna do it is I'm first gonna ask you all like what you think, how you would answer the question, and then if you're right, then I affirm that. If you're wrong, then we correct it. Um, so I'm gonna ask you. Bethel already gave his answer. I'm not gonna tell you what he said. I'm gonna ask you, Nancy. How would you answer this question for A? Describe the effect of pH on enzyme B. How would you answer that? It's 2 marks, by the way.
Um. Wow, this is really the first question. Wow. Like rocking science right now.
What? Come on, not rocket science. Bethel, you think it's rocket science?
For toddlers,
Um.
probably.
Oh my goodness.
Wow, that's embarrassing.
Very.
Okay. I think wouldn't it affect the effect of, like on like in general?
No,
Face okay.
specifically for enzyme B, based on the graph. Okay.
The effect of pH, if it's over the level of a certain amount, wouldn't it be like, wouldn't it, how to describe it? Like, you know how the pH affects the way it forms? I don't know. So I don't know.
Okay. That's no problem.
But what
Um,
if she just do it like based off reading a graph in
yes,
general?
that's what you need to do.
I
Don't
was
think
talking
of
about
it.
like how the rate of the activity, as in like it'd be a point where like if it's too high, then it'd be like I'm trying to figure out the best way to say,
Hmm.
but I think that's temperature, like as in the rate of, it has to be like a certain temperature for the body to, like, for the enzymes to form and stuff. So I just think about like that, but I could be wrong. So I would say no. I don't know.
See, the thing is, I think this is an easy question because they ask you to look at the graph, and so you're not supposed to think about it in general, like the effect of pH in general. You're thinking about it specifically as it relates to this graph. So as we look at this graph specifically, we could read the graph easily because this is just pH on the x-axis and rate of activity on the y-axis. And rate of activity just means how fast does the enzyme work on a substrate. So how fast or how quickly it works on whatever piece of substance that it has, or how fast does it quickens a chemical reaction or something like that. So when we say rate of activity, that means that is how fast the enzyme is operating or functioning. All right. Now, as the pH, notice that the pH is going up. This is at 7. The pH is moving up. It's going. It's moving, getting more and more and more, all the way up to 14. But as the pH is increasing, right, we notice that the rate of activity is also increasing. Because you see that this is rate of activity. As we go more over to the left, the graph is getting steeper. And I like how Mr. Floyd answered it. He start off with as. That's how I usually start off with these questions. As something happens, something happens. That's how I usually answer these questions. As something happens, something happens. So as the pH increases, right, right, the enzyme activity also increases. But this relationship only continues up until a certain point. Now, the point where that relationship ceases is at the maximum, wherein after that point, after that maximum point of enzyme activity, or we'd say after we reach what we call the the optimum level of pH, then the enzyme activity would decrease, right, as we increase the pH, right? So that's how we answer this question. Now, me and Mr. Bethel was trying to figure out what exactly is this point where we would say we have optimum pH, right? Or we would say, yeah, that's the optimum pH of the enzyme. And so we're trying to figure out what is that point. And so it's between 7 and 14. And so we're trying to figure exactly which number is it. And so that's
Wouldn't
why.
you divide 7 by like 2 and then add it to the 7? Wouldn't you get like it wouldn't be there?
No, you wouldn't do that.
Okay.
No. So what I try to do is I try to use a ruler to do it so that I could divide these things equally to see how we could count. All right. But we know from 7 to 14, that's 7 slots. We have to divide it. Um, we have to divide it basically into 7. Let me see. 7. So how could we divide this thing equally into 7 equal parts? So we basically taken 8.1, because that's how much centimeters it is. We're basically taking 8.1 and dividing it into 7 equal parts. Because that's how the thing is from 0. I wrong. Sorry, my bad. You notice where we start? We start at the beginning of the rule, so start at 0. Sorry. So the 0 starts here. So it's really more 8.2. Okay, so 8.2. So we have to divide 8.2 millimeters. And the reason why I say 8.2, I hope you all can see clearly. This is 0. All right, that's 0. Y'all can see that, right?
Mm-hmm.
And if we scoot over, that's 8.2. So we have to take 8.2 and divide it by 7. And I got 1.17. 1.17. That's 1.17. So that means 1.17. So we'll keep that. So after every 1.17, or if we don't want that, we could actually do 1.2 after every 1.2. But with the 1.7 will work after every 1.7. Let's try the 1.7 and see if that gives us any success. And then if it doesn't, then we'll do 1.2. All right. So 8.2 divided by 7 is 1.17. So that's 1.17. So we're going to count 1 and 17. Yeah, because we're still in millimeters. Okay, so, right, so that means that at every point I'm going to put a little marker to indicate. Okay, so this is 1 point. Come on, that can't be that. It can't be that far. If we do, we're trying to divide it equally into 7, so why are we getting 1.17? I'm trying to figure what that means. 1.17 times that by 7 is 8.2. That's true. Oh, I get it. After every, yeah, basically 1.2. We'll have to do 1.2. We'll have to do one because 1.17, sorry, my bad. 1.17 is essentially, if we really break this down, if we really trying to bring it to the nearest, say, 1 decimal place, this will be 1.2. If we're really trying to be technical, this is 1 millimeter, 1.7. This is 1 millimeter. This is 1.2 right here. And this is 1.3, 1.4, the way to 1.5. So our best bet is just to leave it at 1.2, just for the sake of, because we wanted to 1 decimal point, and 1.17 ain't help us. Y'all following? So already sound quiet.
I fall in the general direction.
The general direction. Okay. You understand how we divided the thing incrementally? All we did was we took.
Yeah, you die about it.
Yeah, I take
8 by 7.
8.2 divided by 7. 7 because I want 7. Because I want 7 intervals. You understand what I'm saying? And so if I do that, I'll get 1.17. But my ruler don't have 1.17. My ruler have 1, 1.2, 1.3. You see what I'm saying?
So you have to round it.
I have to round it. Yeah, I have to round it to 1.2. You understand? Nancy, you following?
Yeah.
Okay. All right, so this is going to be 1.2. So this is 1.1, then 1.2 right here. That's the first space. Then what is 1.2 plus 1.2? What is that? 1.2 plus 1.2?
2.4.
2.4.
2.4. So 2.4. So that's going to be right now. And then we have 2.4. Why do I die 2.4? Not even correct. I mean, that's 2.4 is supposed to be right before 2.5. So that's right there. Good. Y'all see that? So this is 1.2.
Yeah, because it right before 5.
Yeah, 1 and 2.4. What is 2.4 plus 1.2?
3.6.
3.6. So 3.6. Right? And then what is 3.6 plus 1.2?
4.8.
4.8.
4.8. So our next one's supposed to be 4.8, but it's gonna land on 4.5. And that's understandable because we a bit off. You understand? We rounding it. You see what I'm saying? So with that
Yeah.
being 1.5, that's fine. Now, what is 4.8 plus 1.2?
6.
6.
Point.
That's 6 exactly, right? Or we have something to
6 exactly.
6 exactly. All right, 6 exactly. Okay. Oh no, it's not 6 exactly. I feel so far though.
Because you didn't put the one where it's a 5, but the 4 point in the midst.
This
You didn't
one?
put it down.
Okay, let me put it
Yeah.
there again. So let's do this. Then 6.
It's supposed to be a little over the
It's supposed to
5.
be
How?
4.8.
It's supposed to be on. Isn't it
No,
supposed to
wait.
be on 5?
No, remember that. Remember from 3 point
Well,
from 3 point
6.
from 3.6
6.
we have what?
4.8.
4.8. But I said that we can't do 4.8 because this one already is here, right?
Mm-hmm.
So we gotta respect that. If we do 4.8, remember we rounded our thing, right? If we rounded it to 1.2. right? So
Mm-hmm.
that's why we expect for there to be some discrepancy right there. We expect that.
Okay.
The only thing we could do is the best thing we could do is we have um to keep the thing going, like the consistency. We have to go here, figure out how much this is between this interval. That's one. This one is exactly, this should be exactly 1.2. Yeah, that's exactly 1.2. That's good. But this one we have to measure from here. If we do 1.2, it'll be too. If we do 1.2, it'll seem very far away. Are we trying to make it as
It'll
possible?
be far because
It'll be far.
we add an additional.
Yeah,
We add an additional two.
it'll be far because remember we rounded. We rounded from 1.17. That's supposed to be 1.17, and so it will be far because
Okay.
we added more than we needed. See what I'm saying?
Okay.
So maybe the best thing for us to do probably, because if we look at this carefully, right? This is exactly, but this is about one. So maybe the best thing we should have done is carry it lower to 1.1 instead of doing the 1.2, so that it wouldn't be a overestimation, be a underestimation, so that by the time we come here, it wouldn't look too off. Because if we do it here and we do 1 point, okay, 1.1, if we do 1, that'll seem okay, or 1.1, that'll seem okay. So let's do that. Here I'll just measure, and um, I'll just measure 1. Okay, I'll measure 1 off 1. So basically, I just trying to divide it into even halves as much as possible, so that we could get, this is 1.
For the first question, did you write down the answer?
No, I write down answer here. Me write down answer here. So this
So
is,
we're just trying to calculate
we're just trying to calculate the the optimum pH level.
optimum pH. Okay.
So this is 8, 9, 10, 11, 12, 13. So 13 would be like here. Good. Okay, good. So the 7, 8, 9, 10, 11, 12, 13. No, it's 8, 9, 10, 11, 12, 13, 14. Good. So we managed to divide this thing into, we so crazy. We should have keep it, Should have keep it. Should have keep it. We should have keep it. It doesn't mean it does not. It shouldn't. It didn't need to respect that. Oh my! Why did I do it? Didn't need to respect that because that means it's just okay. So we should have keep it. Okay, let me keep this. All right, we should have keep it. Okay, so from the um, I'm gonna put this in black so we wouldn't get distracted. Okay, so pretend that we didn't draw that. From the that's true. We didn't need to keep it because we just continue con and 1.2s, and then it will land us straight to 14. Yeah, we didn't need to respect it. Okay, good. So what we said, it was from from 3.2. Sorry, from 3.6 it was 4.8. Yeah, we should have keep that. So this is 4.5, 4.6, 4.7, 4.8. Yeah, it's fine. I thought that this had to be one of the whole numbers, but it didn't have to. So this is 4. This is from 4.8, so it's 4.5, 4.6, 4.7, 4.8. So it's 4.8 right there, right? 4.5, 4.6, 4.7, 4.8. You see? 4.5, 4.6, 4.7, 4.8. Good. And then we have what? After 4.8 plus 1.2 is what?
It's supposed to be 6.
6 exactly, yeah. Okay, after 6, we have what? 6 plus 1.2?
That's 7.2.
7.2. 7, 1, 7.2. Good. And then 7.2 plus 1.2.
8.4.
8.4. 8.4 will be 8. It's 8.2. 8.3. 8.4 would be a little over, but that's fine. Then we'll end it out at the 14. Good. So that means that this is 8. This is 9. This is 10. This is 11. This is 12. This is 13. And this is 14. So what's the optimum height? I mean the optimum level, the optimum pH level. It's between 10 and
10 and 11.
10 and 11. Which we give that? That's more like a 10 point what? It's like a 10.1.
10.67.
6, 7. Why so low?
5.
A 10.5? Look at this carefully. This is 10. This is
10.8.
10.8, more 10.8. If you look carefully, look at it. This is 10 right here, right? This is 11 right here, right?
Mr. Petite, you know I can't see that. There's just a bunch of...
You can't. All right, let me open it wide. Okay, you can see it now.
Yeah.
Okay, this is 10, right? This is 11. This is where our point is right there in the middle.
Oh.
So it can't be 10.5.
It'll be 10.8 or 10.7.
Yeah, 10.8 or 10.7. If we were to do this incrementally, this will be 10.1, 10.2, 10.3, 10.4, 10.5, 10.6, 10.7, 10.8, 10.9, 11. No, that wouldn't work. So we have to kind of gauge it. This is more. I'd give it 10 point. I give it 10.8. 10.8. Yeah, 10.8. Either 10.8 or 10.7. Yeah, good. Nancy, you sound disturbed.
Hmm?
Good. You sound disturbed. What happened?
Hmm? You took me out on this curve. I don't know.
Say it again.
You said it, not me.
I say you sound. You understand? Or you want me to explain it again?
Mm-mm. Mm-mm. Don't gotta explain it. Mm-mm.
Okay, good. Okay, so we did all that to find the optimum pH level.
All that define where the enzyme get denatured.
Yeah, all that.
I
So
hope
that
there's a question for that, because we waste 15 minutes on that.
I wouldn't say we waste. We needed to know
Well, it
that.
isn't a waste, but
Yeah, them stuff take a while. I mean, you to be honest, I didn't need it as a part of the question. I could just avoid it, right? But now that I have it, I can actually say it in my question, in my answer. So for A, the answer would be the following. So if we look at the graph, we'd say that as the what pH level increases, or we can say to be formal, right? The effect that the effect of pH on pH is a small p, capital H. The effect of pH on enzyme B can be described in the following way, or in the following manner if you want to be a little more. As pH level increases, the rate of the enzyme activity also increases until um, until the optimum pH optimum pH level is reached, or we could say is attained at this level, namely 10.8. This pH level namely 10.8, the enzyme's rate of activity is the highest. After this point, as the pH level increases, the rate of the enzyme activity also decreases. Hence, the relationship between the enzyme activity before, let's say, or we could say before. Anyway, I don't want to say that. I don't want to extend some more. But if I were to, I would say that before we arrive at the enzyme at the optimum level, the relationship follows a direct relationship. But after, it is inversely relational. All right, because after, as you increase the pH, the enzyme activity decreases. Okay, so this is a sample answer to this question. So we good?
Good.
All right. Okay. Now, as you can see, we didn't need to figure out exactly what the pH level was in order to answer this question. That was just something that was nice and cute that we, you know, could do to, make the the um the um to make the question look, or the answer look good. But what does this tell us about the enzyme though? So this indicates what about the enzyme? That the Enzyme what?
Enzyme B.
Yeah, let's see, enzyme B works best in what?
A pH of 10.8.
Yeah, but in alkaline, right?
Yeah, I guess so.
It does not work in acidic environment, which is a pH below 7, right? Because, I mean, if we look carefully, because that's something that we didn't mention up until now, like before like up until now, like enzyme B is not in operation during this period. You see that? Between 0 and 7.
Yeah.
Like it absolutely is nothing happening. And but after 7, then it start working, right? And so we see that enzyme B does not function in acidic conditions. Okay, so that's also something worth mentioning as well. We good with question 8?
Yeah, I'd say so.
Nancy, you good?
Um, I think so.
Think so. All right.
Could
Okay,
you
so
go back to mhm.
right.
if all them if the enzyme diagrams look the same, why would you say that it works best?
It works best in what alkaline conditions?
Uh huh.
Okay, because if we look carefully, right, that's a good question. If we look carefully at where this one start, notice it's at 7, right? And that's when it started to move up and down for enzyme B. Like before that, enzyme B wasn't working. So between 0 and 7, which is acidic, enzyme B was not working. So it started to work between 7 and 14.
Okay, and then it's enzyme. I mean, it wasn't working acidic because
Say it again.
why it wasn't working there.
Why was it working between 0 and 7?
Mm-hmm.
Because it doesn't work, and that's the nature of the enzyme. It doesn't work in acidic conditions.
Okay.
Yeah, it
So
works.
what would enzyme A work in?
Enzyme A would work, Mr. Bethel. Enzyme A would work well
Inside acidic conditions.
inside acidic conditions, right? Because
So
it's yes, ma'am.
there are two different enzymes, basically.
Yeah, they're two different enzymes. Yeah,
Okay, that makes sense.
yeah. Okay,
Okay.
so question. That's why question B says, which enzyme would be best suited to work in the stomach? Explain your answer.
Enzyme A.
A.
Enzyme A. Why?
And because isn't the stomach filled with acidic acid or something like that?
Yeah. What's that? What's the acid in the stomach?
Hydrochloric acid.
Hydrochloric acid, right? And so enzyme B would be best suited. So for question number 2, we'd say, or B really, we'd say
We could walk A for a minute here.
okay.
Environment. Hold on, what? Which is a pH below 7. Thank you.
Uh, so B, we could say that enzyme A um this is because the stomach has hydrochloric acid. What's the chemical symbol for hydrochloric acid?
HCl.
HCl. And a pH of what?
3.
About 2. I'm surprised that this is for 3 points, bro. I thought the first one would have been more. What else do you think they would need? Uh, and
Um, I think they want to explain enzyme A work best in
acidic, yeah.
conditions, and then
And then make
what
it basic.
conditions your stomach in.
Yes. So I think we should do that. Enzyme A. This is because enzyme A because based on the diagram. I like that you said that connecting the two. We're gonna graph enzyme A works best in an acidic environment. And the stomach has a hydrochloric acid which makes that environment acidic thus. Okay, good. Okay, so next up would be
So you're gonna say that's providing the optimal condition for the for enzyme A.
you could say that, but I already say this is because you know what I mean. So it's kind of like I already said at the beginning, so it'll be redundant at the end. You know what I mean?
Makes sense.
Yeah. But I would prefer to say this is because at the end though. I fine. What is a sample solution? So explain it to the best of your ability and as thorough as you can. So I'm not
Just
saying
just try to get your points.
yeah, just try to get your points. Yeah, run on. Um, okay, so that's that, and then next up is explain the role of the enzyme almylase during seed germination.
Well, I wonder if I could cheat for points with this one and try like explain what the enzyme amylase is for. A enzyme amylase is for breaking down of starch,
Uh-huh,
the glucose.
uh-huh.
This would benefit the seed during germination because seed uses glucose for food.
Okay,
So that's why I try to get at least 2 points for that one.
yeah, yeah. You're in the right direction. Uh-huh. I mean, you said the answer. You just,
And then I guess you could explain germination too for the next one.
which is growth of the plant, eh? Uh, we'd say, oh my god, it's cooperating. We'd say um amylase, sorry. So amylase is needed to break down or digest starch stored in the seed into glucose. Glucose is necessary to carry out respiration, to create energy needed for the germinating of the seedling. Okay, so we good?
So you get your first point from the breakdown,
Mm-hmm.
amylase breakdown starch.
Mm-hmm.
Second point is glucose is necessary to carry respiration.
Mm-hmm.
So we're at third point in this.
Well, I tell them how okay, yeah, I say needed to carry respiration, but like what specifically, right? So to create energy needed for the germinating of the seedling. So I connected back to the whole process of germinating and what is actually there for to produce growth in the seed. So
All right, all right.
yeah. All right, Nancy, you good?
I'm here.
Okay. All right. Any questions?
Mm-mm.
Okay. All right. So next question.
Ow. I'm.
Explain the function of enzymes in laundry detergents.
Isn't it used to take off like the food particles off? No, let me let
No, no,
Floyd
no. Go
go.
ahead. Go ahead.
We got this.
Go ahead. No,
Yeah,
question.
no, go ahead, go ahead.
Go ahead.
I was just saying I want to hear Nancy's opinion on one of these.
Definitely. She need to talk.
Um, isn't it used like to take off like in laundry, like to take off them? I remember we did an experiment on this in class, like to take off a fabric. Like, so doesn't it helps take off food stuff off to like clothing? I don't remember too well, but I know I remember doing something similar. I don't know if it's true though.
All right, all right.
I don't remember. I don't remember.
Definitely.
Yeah, I
Definitely.
don't. I don't remember.
Definitely. You good. You're right. You're right. Go ahead, Mr. Blanco.
But I would say, based off this question they asking me,
Uh-huh.
I think they asking me if I know that enzyme function is to break down stuff,
And to remove too,
and how
right?
does it relate to laundry detergent?
To
So I say,
remove, help to remove or break down or whatever. I just bird on my window.
so maybe I could say that the enzymes break down food particles on clothing small enough for water to react with them and take it off the clothing.
Dissolve. Yeah.
Yeah.
I think your two answers find some intersection. Um. See. Okay. How it can be answered is the following. So, enzyme in laundry detergents, or we can say enzymes are in laundry detergents because most stains are made from what?
Bio.
Molecules such as what? Food.
Cotton, cotton stuff like that.
No, molecules
Oh,
such
right. Oh, you mean molecules? Oh,
stains.
sorry.
Yeah, the stains.
Oh,
You know problem. Enzymes help to remove stains by breaking down the molecules such as
my.
starch. What else?
What am I writing? Made from.
Protein and fat. Okay. Right. So enzymes are in laundry detergent because most stains are made from molecules such as food and drink. Enzymes help to remove stains by breaking down the molecules such as starch, protein, and fat. Okay. Um.
Makes sense.
I think that it's related, because if we go on to the next question,
I
um,
said, eh?
that's it. That's
Yeah.
it. That's it for that. In
Thank
paper
God.
three, say that, God. In paper three, you have four questions that are mandatory, and then after that you have
Finally, something we know.
which number two?
Institute?
Yeah, I'm here.
Oh, so you went quiet for a minute there.
Yeah, I know, cause I am surprised that this came.
Could you go back to the what it was again? A slide or PowerPoint? I don't remember. I had my dose of some vitamins, so I on high. I just messing. I had some stuff to release some tension. So I right now, I don't want to say much, but so I focus in really. Can you just go back to the? I don't remember what it was.
The one.
The slide where you had the answer, so I can finish right.
Okay. Oh.
What else I could have mean? Wow,
One.
such as starch. You realize, Loki, everything in biology connected. There's nothing that's ever not connected. There's it, and then they expect you to understand that everything is connected. These people are ruthless.
Very connected.
Just want to know the connection.
Uh, Lord, you need to get on.
Anyway, anyway, Floyd, I will belie you because it's a nice day
Isn't that?
and it's a lovely time,
uh, Number two.
and because it's a Sunday, the Lord's day. I'm gonna let you go.
It's already a miracle for us not to have a headache, right?
Oh, that's what you think. Okay, number two is based off of plants, right? So
All right, let's tackle this.
plants. Explain
Explain
why.
uses of
Oh,
plants.
state two uses of water in plants. Which factors other than that? It's moving fast.
No, I just looking at the questions and seeing, opposing it. Okay, let's go. So the diagram show transverse sections through four leaves. Leaf A is from a plant that receives normal light. Okay. So A is from a plant that receives normal light, normal sunlight, and normal amounts of water. And then we have B. B is
I don't
different.
like this question.
B is different.
They could have given us something easy with plants. I don't like this question.
No, this just you have to know the leaf structure and the function of each part, and that's what this is testing.
This B has a lot of the palisade
Palisade
cells.
mesophil, yeah.
This one has a lot of no. A have a lot of mesophyll, the spongy and it's
M
spacey.
A is normal. A is how it's normally supposed to be.
Yeah,
Um,
spacious.
spacious and everything.
C lax and no, it's D would really no. See,
C C there's no real problem with C except that um
it has a thin layer of what's the thing called on the top after the waxy cuticle. It's just I have to write it down. I don't
yeah, the
remember.
waxy cuticle. I trying to figure why what happened to C would be the problem. I see no tremendous issue.
No,
Except
even
that
it,
these things are deformed, look like
but
in
all of
A.
them deformed.
No, but in A it's more you want to say like it's more regular. Like they ain't all like
No,
it's
all of them look like dots on.
come on. But this one have excessive waxy cuticle though. I don't know why that is.
Yeah, they have a lot of the
Yeah, too
waxy
much wax.
cuticle.
Anyway, suggest which leaf comes from a plant that is adapted to grow in conditions where water supply is short. Oh, that's easy.
D,
D. Why you say D?
because that I don't want to lose water, so
Yeah, the
double
waxy
up on that
cuticles.
cuticle.
It triple
Exactly.
in on it to,
Yeah.
to reduce water loss.
Yeah. Yeah.
So what the plant always close it because
It's just no. It's waxy cuticle. It's just
no,
um.
I mean as in the way the guards are is to reduce the water loss too, so that like it'll always be closed then.
Well, let's look and see. No, there's no the guard cell is fine. It's just that on the upper surface, they didn't want to lose leaves in the upper. I mean, don't lose water from the upper side.
Wow, this chair is difficult, man. Oh, anyhow,
Bio is difficult.
I never said biology.
You say bio is difficult. It's easy. So A has to be.
Bio, biology is a fun subject.
Amen. Because we soon
I
go into some rocket science soon. So we ain't
no,
reached that yet.
I only was messing because I don't like enzymes. I never really understood it in school.
Uh, our teacher, I remember she just doing one whole section on enzymes. Enzyme this, enzyme
The
that.
only way I understood it is when they did the experiments. Like I was like going on, it's like, can you just go through an experiment with me? So I can understand. And after school, like come and did the experiment. That's how I know clothing wise. That's how I
Yeah,
understood it. I didn't. She had some stuff. I had to go after class and tell us, say, okay, we gotta put this into play.
yeah. At least y'all did experiments. That's good. Explain why you choose this leaf.
I think we did one with the button thing, where they multiplicate. That was so nasty. Oh, that looked so good. I was so
With what?
stoned.
With what?
It was something where we put under the microscope and then it was like split and it was keep split. I don't remember what experiment that was.
Oh, that's thing that's probably meiosis or mitosis.
Oh my! I was so disgusting. Like I was like, what is this? It just keeps split and then it started to join and I was like, I was just gone. Like I didn't want to touch anything after that. Some of them experiments. The same like videos you show me. I'm gonna practice some experiments on the testing for starch and stuff. I feel as if because as a person I gotta play around with it and I mean
Ah,
to. So I watch the videos, but I gotta because last year I did it, so I can play around with it again. See if I could understand it. I gotta play around, get the feel. Or Mr. Petit, or you could do video showing us testing for starch
ah,
and stuff.
ah.
I like the plant strip thingy. I want to do that. I just want to know where I could get the solution from because I don't remember last time. I think I asked my teacher to get it for me, but I need to find a way to get the solution. I want to test it out. That's the only way you learn
Yeah, for real.
and practice it. See if I can do it.
That's rain or that's someone frying some.
Why are you deep in my host, Mr. Bethel?
I trying to figure why you so deep.
You want to come for Sunday dinner? You could come.
Yeah.
You're invited. You're invited.
Okay,
Come
okay.
on.
Thank you so much.
You're invited. No love lost. They're making dinner, so I'm
I
excited.
was just asking because that was kind of like heavy.
Yeah, they're prepping for dinner. You're always invited to come over. It's a lot for everyone.
All right, thanks. But I was kind of a picky eater, so
I couldn't find no cake today. We can find no cake in the store. I was like, my that's it. Looking forward to cake. While I'm on a break, I could eat the things I love.
oh, Mr. Petit, this is unrelated, but I did eat vegan food Friday from one vegan restaurant.
I don't know if it's me, but every time I go to a restaurant, have vegan food. It always is be bland, but like I don't understand this. It's be so bland and just
It
kind of.
it was vegan curry.
Dad knows, you lose me. I went and had a vegan burger. It was really nice, but I just feel as if the sweet sauce they put on it, I was like, eh, disgusting.
I ain't lie, I eat it. It was edible, but
It wasn't bad to
I could
eat.
taste after I could taste the plant. Although the chicken really close to the real thing. Like I know I could taste even like the roots and
Oh my god.
That's how I felt.
like I could taste the earth and
Oh gee, no, I had one vegan burger. It was alright, but I think they tried to make it sweet or trying to make it like I don't know what it was. It was so okay. I like bitter food, so for them to put that sweet thing up, I was like so scorned by it. I was like, this is what Miss Petite eats. Oh no, this is not it.
All right, so I just was trying to explain why we chose to sleep. Obviously, we understand why. We could say it already. I just wanted to put in the words. So I just say that, of course, the answer is D. This leaf is chosen because compared to leaf A, this leaf has a thick waxy cuticle. This characteristic is important because since this plant lives in the area of short water supply, the excessive waxy cuticle ensures that sufficient water is saved for the plant to use. All right, are we good?
I say so.
Okay, that's good.
What question? Okay, they say why they choose this leaf. What you mean? A D, right?
Yeah, D. Yeah.
It's referring to D. Okay. T.
Yes, ma'am.
Did you hear our conversation prior to this?
Conversation.
Okay, thank God. If you didn't hear, then don't worry about it. We didn't hear.
Oh, explain how this characteristic. Oh, we answer A and we answer both together. Because they say explain how the structure of the sleep would help the plant to survive in dry conditions. So the answer for this one's supposed to be because it has um a thick waxy cuticle, and the answer for this one would be the same thing I have here, that connecting now the waxy cuticle to it's conservation of water. You know what I'm saying? Like I answered it ahead of time.
Yeah, I understand.
Okay, Nancy, you get it?
Um, yeah, true.
You sure?
Mhm.
Okay. Which leaf is adapted to take the most food? Give a reason for your answer.
That one with the overflow with the palisade cells, right?
Yes. It say to take though. It say to take to make. Oh, I say make. Yeah, 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 yeah.
Sorry, sorry. You can move it. Sorry.
Which leaf is adapted to make most food? You agree with her, Bethel?
I wasn't looking. I was looking up trying to find that vegan restaurant where I eat from,
Oh
but
my goodness. Which leaf is adapted to make the most food?
B.
B.
yeah, B
Why?
because it has so
It's
much.
palisade cells. Too
Yeah, so
much.
much chlorophyll.
Palisade mesophil, right? And
It isn't palisade cells.
no, palisade mesophil.
Add the miso.
Yeah, leaf structure.
I just used to say in ice type palace and everything. Wow. Thank you for correcting me. No one can ever corrected me on that.
Yeah, palisade. That's what's called.
Oh, palisade, miso fill.
Yeah.
Oh, hang on, bit in my notes.
And say it again. Palisade mesophyll. That's what we always call it.
I used to say palisade cells.
Palisade cells is fine too.
Okay, palisade miso fill.
Yeah.
Palisade. Let me write that down so I wouldn't forget.
Mesophyll function. It has
Oh,
a
it's double L.
it has a lot of chlorophyll,
This is B.
and it contains majority of chloroplasts within the leaf. Thus, it is the main site of photosynthesis. So, um, this is gonna be the place where, since we have a lot of them inside the cell, excuse me, since we have a lot of them inside the cell, I mean, yeah, inside this leaf, that means more, the rate of photosynthesis is gonna increase. Understand? I like this. The rate of photosynthesis is gonna increase, and so we're gonna be able to make more food. I don't have to write that, eh? Like, do I have to write that?
You could write the reason so I can have I can properly have it down
All
because
right.
I'll put my own slang in there.
Okay, I'll probably have it down. Okay. All right, no problem.
Okay, or you could dictate if you feel as if
No,
that's
let
too
me do it. Let
much.
me copy because I know how you feel. Because that's how I feel. I want my teacher to feel like it, right?
If it's too much work, I tell you, you don't gotta do all that. If it's too much work.
Come on, that's fine. Why no biggie? Please don't make it a big reason. So, okay.
Because Lord knows we don't start sentences with because, but Lord bless visibility. So
Oh, because I mean, say, all right. The reason. Oh my goodness. The reason.
I already started with because you guys don't. I already
The
started.
reason
I can
this
keep
leaf
going.
is chosen.
It in here. I use it to know laptop touches should be right in here. Oh, you can plug mine too. Mine don't want cut on, but
If we continue,
here.
what's that's the question?
Oh yeah, Nancy. I had a question to ask you right away.
Yes, sir.
When you went to that language exam, it was like early or it was late inside the door.
I was early.
Okay, so you gone like with the bundle then.
Um, I don't remember quite because I just know I was alone. I could say that.
No, I mean like you gone when like everyone was there, or like you gone when like the only last people was left to go in.
No, I went when I went. I was kind of like the first couple ones in, but
Okay, okay, okay.
yeah. While everyone was roaming around looking, but they think I was done sitting down, we're looking at the time.
Wow.
Yeah, because I don't. People just walk around looking for numbers. Take that long. I already know. Okay, if it's one, if this side of the room is one, I don't know. I in like the second row because my number. I wasn't into walking about it. So yeah, I was sitting down basically, looking at the stars.
What are they? Bassa who?
Edric Thompson, right? His name is very familiar.
Eric Thomas. Eric Thomas.
Is it a Thompson? Why keep saying Thompson? Like Thompson for everyone, but I don't get that.
Did you be the exercise or they?
No, that's my driving movie playlist.
Wait, you actually is
But for
listen
what?
to like did you actually listen to like have that inside your like your car playing right that music right?
Yeah, the him talking.
People called me old and weird and
No, that's me.
crazy. Like my teammates dragged me when they realized I listen to motivation speech and I don't have music.
Which contains some chloroplasts. Um,
That is a bit strange, though. I ain't
What you mean?
like I like listening it in the car.
No, I just don't listen when I get my mental mind together to run. I just listen to it.
We need that. I need that. I love that all the time. My
No, I ain't never that serious.
when I say all the time, I mean if I
I
Yeah, Mrs. We understand you. You always want to be encouraged all of the time. That's no problem. That's some people. Some
but
people on the planet.
like, but do you even need that? Because you like I wouldn't say made it right, but you a lot of steps forward than most people.
that's the thing, That's exactly. See, okay. Um, the best example I can give you is the example of an alligator, right? Um, some people think that you can't kill an alligator. But it's easy to kill an alligator. I can kill an alligator with my bare hand. And
No, the alligator can eat me. No, the alligator can eat me. No, no, it can eat. No, allow it.
I can kill an alligator with my brother.
No,
No,
no, it
listen.
can eat
No, listen
me.
to the point. Listen to the point. Listen to the point. I can kill an alligator with my bare hand. Excuse me, mom. Can you give me a moment, please? Bye. Please, mom. Let me how I kill an alligator with my bare hand. When the alligator has just finished eating, right? The alligator is full. He's satisfied. And he is almost to a state of paralyzed. At that point is where anyone can kill an alligator because he's essentially wasted. When they eat big. And so if you get an alligator at that point, you could kill him easy, right? And so I say that to say, people who reach some measure of success, right? When they become satisfied, when they become full and they become big-headed, um, then there's no room for improvement. But for me, I always know that there's another gear for me, and so even though some people say, "Oh, you have made some measure of success," that's all right, but there's always another gear, and so I'm not gonna say, "Oh, I made it and then I can't, work to improve." I have to stay hungry. If I don't stay hungry, then bet I dead, So that's why I don't want to become like a fat alligator.
Yes, sir. That is the mindset of running. Yes, I love it. It's the mindset. But in the literal sense, alligator can eat me because I too animated for this. I'll be like, I'll look at it and I'll just try choose expressions to make it calm down. And then by the time to eat me, then someone could kill it. But no, I'm gone. Either it kill me or I kill it. But I'm gonna kill it because I could be too terrified.
Yeah. State two uses for the plant. It's easy.
That's a good question, you know.
The one uses the creek
It's
What?
for
water.
the production of
Tea?
oxygen.
Yeah, I got a little bit tea. Yeah. I got no, I want tea.
Say uses say uses of water for a plant.
Oh,
Water.
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 Hydrated, right? Is that a simple one for this?
Hydrated. What you mean by hydrated?
Hydration.
Plant use water to carry out photosynthesis.
And then also it used to what is it called now? I don't remember. Anyway, sorry.
Transport.
I mean
No.
that. Go ahead.
Isn't it used to carry stuff around the body? Because remember when they was
We're
talking
talking about the
about the
plant.
Tran-
phloem and the xylem?
We're talking about the plant.
Oh, plant. Sorry. I done lost.
Okay, if we look at
So what are the uses?
okay, if you look, sorry, man, if you look at the formula for photosynthesis, right? All right, you'll see something.
Something with the herb.
So a plant is interesting, right? Because the plant, this is the formula for photosynthesis. So what is this? This is what? H2O, right? H2O, right?
Correct.
Which is water, right? And so what the plant does is that it uses water and carbon dioxide. This is the reactant side. So it uses water and carbon dioxide, combine them in the presence of chlorophyll and sunlight, and to produce glucose and oxygen, right? And so the plant, in its structure in the chloroplast, uses water to make food. And so this is another beautiful equation here showing you water, carbon dioxide gives us the sugar and oxygen. And so we'd say that the use for water for the plant is,
Could you go back there quickly, please? I really wanted to take down the equation.
oh, you want to take down the equation? Okay, no problem.
Yeah, because I lost. I don't remember that. So I might
Me
have the
either, me either.
opportunity.
Oh my goodness, the
Yeah.
same.
I only know the word one, so I want to write this one down, please. Could you go back to the first one where it said chemical? The chemical, please.
Oh, okay.
That one was. This one is really nice.
That's the same thing, you know.
No, I like this one. I like this one better.
Literally the
Hold
same
on,
thing.
wait. I gotta
The
write it
same thing
over.
with the curly brackets.
This one, I think I'll understand it more. So
Mm. They saying the same thing though.
at this time, this one, right? And then arrow C6 H12O6. I knew the word one. I don't know why they tell us only the word one though. O2. Thank you.
Good. So water, they say two, but we could give them at least three. So water is necessary, right? For photosynthesis, right? Which is how plants use energy from the sun to create their own food, all right? And also food for us. Um, uh, so another thing that plants use water for is to prevent them from overheating, all right? And so I say that because water is evaporated on the leaves in a process called what?
Transpiration.
Transpiration, which keeps the plant from overheating.
What about from drying out?
From drying out? No, they would.
Dehydration. That's what I was asking you about.
No, but dehydration. Well, that's true. That also that yeah, that's true. From being shriveled, right? That's true. I like that one.
To create downfall.
By the way, who is Gailey?
Oh, my laptop is tripping out. I put to take it to the store, but I'm on her desktop, and my information is kind of on her desktop, so I had to use her desktop. I don't know. My my laptop only charges when it's off, and when I'm on it, I don't know. I must have to change the battery. Some told me that the month because I had it like a year or two. I think 3 years now, and they told me that time for the battery to change. So I guess I gotta take it to the store to fix it. I don't know.
Okay. I saw the Gailey Joseph and I was like, that is one you can pronounce it.
Yeah, it's my sister's name. Don't repeat the name though. She doesn't want you guys to call her name.
We are not worthy.
Thank you, Adam. That's us. No, sir. I paid for. I'm confident. Put it down. Put my confidence down, please. I paid for those.
Okay, solvent properties and good enough. Solvent properties. So that'll be it carries so water carries nutrients and solutes required for growth.
So sorry about the noise. I had to mute. We were family discussion. I'm sorry about that.
How do you ever study in that environment?
I go outside and I have this chair outside and I study. And then sometimes too, they're very helpful because they're smart. They're really bright. My sisters are really smart. So if I get lost, I could turn to them and I may. So
Yeah, so I think we could go down with these three. Also, overheating helps to carry nutrients and solutes throughout the plant, and is necessary for photosynthesis. Okay, next up is which factor, other than light and water, if increased, could cause an increase in the rate of photosynthesis?
The increase of palisade mesophyll.
Increase in palisade mesophyll, that's true. Um, so, so if we increase the
I don't understand the question. Sorry.
good question. So they're saying if we want photosynthesis to happen faster or more efficiently or at a greater rate, that is to say, um, we want um, we want to make more food then. We want the plant to make more food. Like what could we do, right? We could increase the number of palisade mesophyll. The next thing we could do is we could increase.
Why would you increase the number of palisade measles? Okay. I understand that part. Sorry. Oh,
Also,
that's what you mean. Sorry.
yeah, you can also increase um the amount of carbon dioxide the plant receives, right? You understand why would we want to do that?
Because plant also uses it
Yeah,
to eat food.
yeah, because if we look at the formula for photosynthesis, we find that on the reactant side, sorry, let me bring this down. We find that on the reactant side, we have two things: carbon dioxide and water. So if we increase how much water the plant have, we could increase photosynthesis. Like if you increase the reactant side, you could obviously increase the product side. That makes sense because, like, I mean, if the more reactants you have, the greater the product, right? It's like Kool-Aid, right? Like if you want to make more Kool-Aid, like what you need? You need more water, you need more Kool-Aid, and you need more sugar, right? You will have less Kool-Aid if you have less sugar, less water, and less Kool-Aid. So similarly, for photosynthesis, If we have more water, more carbon dioxide, more sunlight, more chlorophyll, then we can make more food. So if what would we increase? If we want more chlorophyll, we could increase the palisade mesophyll. That'll give us more chloroplasts, and then we can have more chlorophyll. If we want sunlight, well, that's the greater light intensity. But they don't want that. They don't want light, and they don't want water. So we are left with increasing the amount of carbon dioxide we can get, and we are left with increasing the amount of chlorophyll the plant will receive. And that we could do that by increasing the number of palisade mesophyll and increasing the amount of carbon dioxide the plant receives. We good?
Yes, sir.
Nancy, we good?
Yeah. Could you go back to the slide before this, please?
Okay.
Thank you. And wait, you okay? Hold on. Just one moment
Right there.
for growth. Okay, you can move it. Thank you.
Okay. All right, next up would be explain the importance of light and chlorophyll to the process of photosynthesis. Explain the importance of light and chlorophyll to the process of photosynthesis.
Without light, it wouldn't make its food, right?
Yeah, but how?
Mm, that's a great question.
Well, I know the chlorophyll you uses the light
That's a great question. Honestly,
to
Good
make
question.
explain. I can't tell
glucose.
you. I can't tell you. Explain the importance of light and chlorophyll to the process. To the process of.
And
Wait,
without
hold on.
chlorophyll, the light
Is
has
this
no function for the
isn't
plant.
it? Doesn't this go back to the equation?
Well, if we go back to the equation, go back to it.
To the chemical equation. Um, sunlight and chlorophyll. CH. I mean C6H12O6. I don't know.
So the light is a catalyst then.
The light isn't a catalyst. I mean, I understand why you ask as a catalyst because it's all we trying to say is it's in the presence of. That's all. We ain't trying to say it's a catalyst.
The arrow represents what?
Say it again.
You said something before.
Oh, the arrow means that this produces that. But he asking about the stuff on top of the arrow, and sometimes they mean the catalyst that makes the process happen faster. So sometimes when we have these stuff in front and on top of the arrow, at the bottom of the arrow, it is referring to substances that would quicken the chemical reaction. But here, when we have sunlight and chlorophyll on top and the bottom, we don't mean that it's gonna make photosynthesis like it's not gonna act like an enzyme. Like what we are saying is that we need, in order for this reaction to take place, we need to be in the presence of chlorophyll and sunlight, as we're saying. Okay, so sunlight. So let's talk about the light for a moment, right? So plants, this is for light. Plants rely on the energy of the sun. It's very important. The energy of the sun, or the energy in sunlight to produce the nutrients that they need. Sunlight's job in photosynthesis is to provide energy. The sun releases energy in the forms of heat and light. So we need the energy, we need the light, um, because light is a form of energy.
But are you giving us more than 1 point? And
And the light?
yeah.
No, I think that's it for light. You need the light for energy.
No, I mean as in, is all of that entirely 1 point?
Yeah, one for light. We ain't reached chlorophyll yet.
No, I mean as in, okay. The okay on because this asks for 1 point. Like it's a 1 point question for like, but in your question, would this replicate, like, let's say, would this be like 3 points?
It's not 3 points, it's still one. Because I basically said the same thing in a different way.
What?
I just explained, it a bit, Like I say, plant rely on energy and sunlight to produce the nutrients that they need. In
That's
the
it.
next line, I just reiterated it and said that sunlight's job in photosynthesis is to provide energy. I just said now in what type. So the sun releases energy in forms of heat and light. So that's it.
So the second sentence would be like the explanation.
The explanation, yeah, of the first.
Mm, okay, I add in my notes then. Explanation.
So why do plants need chlorophyll though? So we know that plants need the light to produce energy.
Yeah,
Why do they need the plants? I mean, sorry, why do they need the chlorophyll?
because isn't chlorophyll? But isn't that where they get like the energy and like this stuff from to actually get the process, like actually to do the process? Because without
What do you
energy,
mean?
how can the process? I'm trying to tie it in. Like
Hmm.
they need energy, right?
Hmm.
So chlorophyll automatically. How could you do something without energy? That's what I'm thinking. How could you do something without energy?
You need
You know what I
energy,
mean?
and they get it from the light.
Continue. I have to.
So the chlorophyll uses the not well, I wouldn't say use. Chlorophyll transfers the light energy
What you mean?
into like, well, I guess you could say use. It uses light energy and it uses it to make glucose. It can transfer light energy to make glucose, chemical energy.
Okay, what it does, right? Let me which sorry, let me my God, sorry. Okay, so let me put this underneath. So chlorophyll helps to channel the energy of sunlight into chemical energy. With photosynthesis, chlorophyll absorbs, sorry, chlorophyll, spell it wrong, absorbs energy,
What's another word for channel in this sense and like the way it's being used?
convert in a way,
Convert?
yeah, in a way, with photosynthesis, chlorophyll absorbs energy and then transforms water and carbon dioxide into oxygen and carbohydrate. So the chlorophyll is needed. It's one of the it's one of the necessary things that you need in order to make food, and that's why um, we can't make no food. We have no chlorophyll. More than that, we're kind of handicapped in the sense that you know we take in oxygen, wherein in photosynthesis, oxygen is the byproduct. Well, that's another problem with us. But chlorophyll helps helps to channel the energy of the sunlight into chemical energy. With photosynthesis, chlorophyll absorbs energy and then transforms water and carbon dioxide into oxygen and carbohydrates.
Could you give me one reason why you say the body can't make their own food?
Yeah, one, like I said, one, we don't have chlorophyll. And the second reason is that um, we we take in oxygen, whereas in photosynthesis, oxygen is a byproduct, right? So oxygen is released as waste, and so um, carbon dioxide is taken in as something that is good, and so that's a problem with us because we take in the bad stuff that we take in the plants' garbage and the plants take in our garbage if you wanna understand it that way, like so that's why we can't produce food because in order to make food you need carbon dioxide to come in, but for us carbon dioxide is a problem for us as a waste product for us, so that ain't an happening. Okay, next up is mm, so that's good. Um, this is number three. I wonder if I want to do number three.
Uh, that'll take a lot of time.
That's plotting. Um,
We do enough of that in maths and like
this is plotting, man. We should be able to do that. We can come back to number three.
That's homework then.
Yeah, do number three for homework. Yeah, do
All
number
right.
three. Let's do number four. Mm. Um, okay, so define the term genetic variation. So what the diagram shows two bar charts, which represents two types of variation. Sorry. So this first one says define the term variation as it relates to living organisms.
They mean as in what? Height and stuff like that?
When you hear the word variation, what comes to mind?
Type.
Say it again. Type
like differences throughout the same species.
differences.
Yeah.
Type
And
of
it's
Like she say, height. Some people tall, some people short.
so you mean genetic differences.
I was just trying to figure what they mean
Yeah,
by living organisms related to living organism, like as in height, weight.
So variation is defined as the genetic differences
Environment and stuff like that. So that's what I asking.
among
But the term relates to
relating to living organisms. So living organisms, those people who are alive. So genetic differences, variation is genetic differences among sorry among organisms of the same species. Variation is the genetic differences among organisms of the same species. Nancy, you asked what would be a replacement of the word um, channel. As I think about it, I think the better word would be, if we're trying to replace it, would be not convert but use.
use.
Yeah,
Okay.
not convert, use.
I just was trying to find ways so I could
It's planning, I know. But
okay, used. I didn't want to like use word.
variation is genetic differences among organisms of the same species. Um, Now the next question says,
One
um,
minute, 1 minute, 1 minute.
don't move it.
Yes, sorry. Differences. Genetic differences.
Genetic differences, yeah.
Oh, so like as you're saying that, okay, if someone's tall, that being like inside, it'd be like a generic gene then.
What you mean?
Oh, okay. Let's say someone is 6'0", and another person is, let's say 5'7" or something like that. It goes by their genes then.
So you know that for for not you not for the DNA, not everybody DNA is the same. You know that, right?
Repeat that one more time.
You know that for the DNA, not everybody DNA is the same.
Yeah.
So genetic variation is the difference in your DNA among individuals or differences between like populations and stuff like that.
Okay.
So certain uh variation examples would be like like eye color. So people with blue eyes versus people with brown eyes, stuff like that. You know what I mean? It even works across like species too. Like different types of shells vary in terms of their color, like different shades of brown, different shades of gray, different shades of orange. You know what I'm talking about? Like in a snail shell.
Yeah, basically no two people are alike.
Yeah, yeah.
Yeah. No, that's crazy though.
So we looking at stuff like eye color, blood type, um, stuff like that.
What would you do if you met your doppelganger?
I don't know what that is.
Your clone.
Boy, that'd be weird. That'd be creepy and all. Cloning.
But would you want him wrong or like
I
would you
wouldn't.
want him
I
like
wouldn't.
far away from you?
Far, far away. I
What
wouldn't.
you talking about?
You talking about the clone? I wouldn't want myself around him. This would feel weird, especially if it's in synthetic. You know what I mean?
What you mean by in synthetic?
When I say synthetic, I mean like not original, like not from the creator or something like that. You know what I mean? That'll be weird, way. But if it was like naturally occurring, then yeah, I have no problem with that. Cause I mean, but shoots, gee, doves, something like that. It's weird and creepy. All right, give the correct terms for the type of variation shown in bars P and Q. And so,
Q
huh?
is okay. It's a number of. Is that number of students or no? What is that sideways?
That's the number of students.
Okay, this is discontinued P, and this is
P.
continued.
Very good. So for P, it's discontinuous variation. Oh, I'm surprised you know this, Nancy.
I'm just not good at enzymes and some parts of the leaf, but everything else I got at. I got you. Like, I'll still drop a sign good at, so you'll know.
Okay. Discontinuous
Yeah,
variation.
this was easy. I remember acing this in classes, man. No problem.
Okay. And then
Wow, you actually learn stuff in class.
Wait, what? How you want me to learn
that's
them?
what I'm saying.
Oh my god.
I thought you just go to class because you had to.
Wow.
Yeah, really. All right. So
I
P
was
is
in biology, the most talkative one, but you couldn't tell me. I had to get it. So I had to get it.
so you didn't take the BGCSE in grade 10. I mean 12.
Did I take it? I don't remember. I was looking at my results. I don't know.
Oh, okay. All right. So
So
Wait,
now they
I
out of school then.
um I'm thinking now. Wait, Flo, you had a question? Sorry, I didn't hear you.
No, I was asking if you were out of school.
No, I'm still in school. Miss Petite done gone to the next question. Let me finish write down the notes. Wow.
what school does go to, Nancy?
Homeschool, right here.
Oh boy, Nancy, don't go to no school. Nancy, you know
I
Floyd being,
technically somewhat
Floyd
do.
being. And she right there. She played it all so good. And Floyd right there like,
No,
yeah, yeah. Floyd,
I did. Okay, what do you mean by school? Because I do attend school, homeschool.
talking
I'm
about.
home and I'm at school. I have people I message and I need help and I do
Here's a
school.
list
But
for examples of variation.
wow,
Hold on,
ignore me
hold on,
like
hold on,
that.
hold
Ignore me like
on.
that.
For
That's
each
fine.
example, state which bar chart P or Q could represent it. So when we talk about height, which one could represent? Um, is it continuous variation for height or discontinuous variation for height?
Continued.
Continuous, Floyd, what you think for height? Continuous or discontinuous?
um, You won't really explain what those two means.
Okay, so
Yeah, I have a book that's but it's TLDR.
What is
okay,
that?
What TLDR
Yeah.
is too long, so I didn't read.
Oh, Mr. Bethel, I am not in school. I graduated last year, to be clear.
thank you.
So how come you taking BGCSE bio now?
Cause I didn't do well. I think I didn't take it, and if I did, I probably did bad. It had to be one of those two.
Remember
I
Bethel?
don't know.
Remember she from the COVID-19 class.
Oh, okay, okay.
Yeah.
Yeah, but I think I have like I passed couple already. I know the ones I took. I passed. I think it's math and I think I might got a D. I think yeah, I got two D's and I got to take them over because I did core. I didn't do extended. So now that I'm doing it, I think so. I think biology was one.
So for when we talk about discontinuous and continuous, Floyd wants to know like precise definition. So for discontinuous,
That means something that it's only you only have mandatory options and never be like a different option or something you never heard of.
So like blood type then.
Yeah, like there's only A, B, B, O, right? I think so.
yeah. So
You never hear
So
anything random.
continuous means like it's a endless variety then.
yeah, so continuous is like
Okay, I
discontinuous.
don't need it no more then. That's all it is.
My boy, you never let him explain it
I
though.
didn't even I didn't even explain it properly. Think about it.
My boy, don't
I
catch
just wanted to
on.
know what it is. I can forget that.
Boy, don't catch
There's a
on, boy.
specific definition. For discontinuous, it's finite one, and it's um it's space. That's probably the best way for me to I like to think of to, to um to think about it. Spaced, or I could say we have the way I remember it is that we have skipping. So there's skipping of numbers. All right. That's ng. For continuous, we say it is infinite. I don't think these are necessary. I don't think I don't think it have to be it's necessarily finite for discontinuous, but it have to be spaced and skipping. For continuous, um, for here we have no skipping, and so at any interval, there's an infinite number of values that can be chosen. And so, for example, here, uh, continuous would be like 0, 1, 2, and 3, right? And the reason why this is discontinuous because we skipped, right? Between 0 and 1, we didn't mention 1.5, right? We didn't mention 1.6, neither 1.7, neither 1.8. So we skipped, so that's why it's discontinuous, right? But for continuous, we never skip, right? So for example, we'd go from 0 and then we'll go like we'll go what's the very next thing right after 0 and then the very next thing, the very next thing, very next thing. Like we never skip numbers, right? So we
I
can't.
have a question, Mr. Petit. My question
Uh-huh.
is the eye color continuous or discontinuous? That's a tricky question
That's
because
tricky, right? Yeah,
I notice we have a lot of eye colors, but then we have very few. So what is that?
that's a good question. I have like maybe I don't know if they have a general consensus on that. Because it depends on how you think of it. Let's see. Because then, let's see. Eye color.
Ow.
What this continuous
Don't
variation.
tell me a bunch of like different answers.
They said that color is discontinuous.
It's just bang. Okay.
Discontinuous, they say. So stuff like blood group and stuff like that. So here for continuous and discontinuous, a wide range of values between two extremes, right? And then here there are distinct groups with no values in between, right? So we skipping. So I like this definition now. We could go on and talk about um, but some people um put it under continuous though, Nancy, natural eye color.
That's what I think because they have a different bunch of different answers on the internet. I don't because I just want to know in case
This
that
one said
comes.
this one said of course limited range. Um Limited range. So we can't have an infinite number of it. Um
Because a lot of people have different a lot of different eye colors. Like there's never someone. I every time I meet someone new from a different place, it's always a different range in the color. Like some have light gray, dark gray. There's always a hazel, light hazel gray. And I mean, I just want to know if that's continuous or
let's see
discontinuous.
how this one answered. So
Okay, well, don't worry about it. I guess they probably wouldn't show that question on us because it's complicated.
yeah,
Yeah, it's complicated. I doubt they'll show it.
yeah, I doubt they'll show it because yeah, even in this one they don't ask it.
Yeah, so
Anyway, yeah, because it's tricky. Anyway, let's go back to this. So this is statistics though. That's how I know the difference from statistics. Let me add to do it. Height would be what we said is continuous because you could be 5.5 inches, 5.57 inches. Like we ain't skipping numbers. So um, this is continuous. Sorry, it's continuous. Continuous. And then we have for blood group. Blood group, of course, would be
That's discontinuous.
discontinuous.
yeah. Show us limited sex and gender. Oh boy,
That's discontinuous.
this one I surprised they have this.
Continuous.
I surprised they have this. Only in the
It's
Bahamas, you know.
continuous because ain't no we don't have only in the States they might say continuous because they got 17 genders. But
Exactly.
here we have
Exactly.
two genders. Do not confuse
Exactly.
it.
Praise the Lord. In a few years from now,
Where you mean here? On planet Earth?
that she mean God, wait, listen to God. Intelligence.
I never said I just love it, Miss Elizabeth. I love it. You just extra. It's okay. It's okay.
Intelligence.
It's continuous
Why?
because everyone level of understanding ain't the same. I ain't gonna lie, it ain't the same. And that's the intelligence, eh?
Hmm. Stay too
Oh,
calm,
I
please.
actually smart. That child. Look at Nancy saying she knows something.
Boy, and
Indeed.
then
You know, it's in the United States, it's illegal to take a IQ test for a job.
Oh, okay. I didn't know
it's
that.
what?
It's illegal for jobs to require IQ tests to
What?
be employed.
That's true? That don't make no
Yeah.
sense. Because for the army, they require IQ of 200 and no less.
But
If you
they make a ways around that. So it's not officially IQ test, but some equivalent to it.
oh, okay, so
But
it's
it's not officially IQ test
oh, they
because
don't term
it's
it.
illegal. They don't. Yeah, they ain't officially IQ, but it's
Oh,
basically IQ, but it
okay.
ain't.
Okay, I have one for this answer. Environment.
Yes, environment. Nancy, you just your topic. It's your topic.
What's the other one? Environment and climate change. No, that'll be part of the environment, eh? Climate change and stuff like that.
Um, Geographical location.
Yeah, but it's not the same as environment.
Yeah, I think so too. Um,
Genetics.
alley frequency. Yeah.
Yeah, it's a number thing. Mm, What else is it? I don't remember
Now
now.
I can tell you the answer that that people who believe in evolution would say, and they would say artificial selection,
Buying. That's when I remember. That was I was thinking about that. Yeah, artificial selection too.
survival of the fittest.
Yeah, and then geographically, some. I don't remember.
Um, what else could affect the genes? Uh, how about your parents' side? Yeah, the variation. Yeah, of course. Family heritage. I'd say that affects your genes a lot. Yeah. Uh,
Health too, right?
health. Yeah, yeah. So sicknesses. So we can say what do you call them?
Family heritage. I remember she gave us a bunch of list of crazy things. I didn't even know that was possible.
How about thing radiation?
Yeah, all these could affect you. That's
Uh,
sad.
mm,
Survive. Yeah. Fitness. Oh yeah, because you could gain weight, you could lose weight.
okay,
Uh,
so the last
fit-
one thing says
fitness, radiation.
Irritability.
irritability. What do you mean?
What is that?
Like you'll have to adapt to your surroundings.
Irritability. So sensibility. You think?
Adaptability.
Oh, adaptability. I don't you mean. I don't need to say irritability. I thought you mean. I wasn't even thinking from bio. I was thinking more of like when you irritate some.
Emotions. Like,
I was thinking what I. I wasn't even thinking bio. I was thinking some
With
psychology.
high
I
milk.
outline how artificial selection could be used to produce a variety of cows with high milk yield.
And they could pull a gene from someone, I mean, from another cow that has
Uh-huh.
the high milk yield, something like that.
breed the cows that only
Yeah,
yield high milk.
Yeah,
from the. That makes sense.
yeah.
Did I say it right?
Humans can selectively only humans can selectively only breed um, female.
Wait, so we can't pull a gene like how we could pull genes for animals?
We don't want to do that. You want to go through all that just to do that?
That'd be pretty cool, but that'd be disgusting and against God, though. Ah, sad.
Honestly, sure.
What?
Now you now you trying to bring us into religious now?
No. Cares is kind of me because that's everything I base off my decisions. So it's kind of natural. You know what I mean?
But that is natural though.
No, I mean like when I make a decision, I like refer
Why
back.
natural? That's not. There's nothing natural about that, Mister. Um.
Bethel? Oh, that's what you mean. I thought you mean like why when I say it was sad, I would say because it's against what I was taught basically.
But if you think about it like a playground, like everything there, for you to play with,
Mm, no.
Okay,
Some things you wanna play with, Mister Bell.
okay. Some things you could play with. I agree with you, but then at the same time, you must not forget your limitations in playing.
Yeah.
There's limitations to playing
There's limitations. It's like freedom. Like you have freedom, but then there's responsibility, right?
with freedom. So yeah,
yeah, but some things for the greater good though.
no, sir. I don't believe that. I greater. It's okay to have that kind of thing, but then do it the right way. You know what I mean?
Do it the right way. And I think, I mean, my thing is some and when we look at how people would be using it, they's be using that, especially the cloning thing and stuff like that. They want to use that to make their lives extend their lives longer, such that
I anyway, but then they still can die. You can't run from that. That will find you.
like this clone the people and then take out their heart and take out their you know
You don't
But
think that's more reasonable? Like they could save lives.
I'm
but
saying
then think of it. Life can have to come to an end regardless because there's The Bible says that the like you going to die eventually, so why prolong your death? But like, what are you staying here
Okay,
for?
you might want to see live long enough to see your dream come true.
Live okay, but then no,
This is what I'm saying.
no.
Okay, with the cloning thing, right? They is build a clone so that they could use the clone as a as a storage place so that whenever their heart failing, they'll take the heart from the clone, or they'll take the pancreas from the clone, or take the kidneys from the clone, or whatever. So now you causing a whole human to be disadvantaged because you want to live longer. And so, like, that
But
ain't.
you wouldn't give them a consciousness though.
But it's still selfish in my
But that's
eyes.
the thing. You cannot say you didn't give them a consciousness because you don't create life.
Thank you. You're not the creator of life.
And
Thank you very much.
once that thing breathing, that's the soul. That's the soul.
Basically.
So you can't say, oh, that's just something I made that doesn't have a consciousness. You know, this ain't no AI.
Thank you. And then at the same time, doing that, you telling yourself that you's God, but because if you have the power to create life, who are you?
But they can't create life though.
But
They
But
we in the
then
image of him though.
they in
So
the
why could we?
yeah, you are in the image of him.
like
He never said that you were God. You are shaped in shaped. You know the word shaped. There's a difference. Shaped.
we in bio. We
You're
in
not the
bio.
original. Okay, relax.
All
We in
right.
bio. We in
This is
bio.
heated,
This
but
is heated.
let's go
No,
back to
I hate no.
Bible.
I had no. I see. I get defensive because I believe in. I don't believe in stupidity. Sorry.
Oh my
Oh,
goodness.
okay, okay. I hear your stance well and clear.
All right, so humans can. So how can we get artificial? How can we get cows with high yield, high milk yield? What we could do is we could only um breed with the cows that have high milk yield, and then the cows that don't have high milk yield, we don't bother with them. All right, and so that's how a person can naturally um you know force nature into um only producing those ones that have high milk yield, and those that have low milk yield, you don't bother with them. Um, and so that's what you say. Humans can selectively only breed female cows that produce more milk with the desired male cow to increase the chances of the next generation of female cows to carry the trait for the high milk yield. And that's how sometimes you would find that certain grapes or watermelons are way more sweeter than the average because the farmer, if they're smart, what they do is they only breed the ones that are very sweet, and the ones that are kind of sour and they don't take that seed. And so as you keep on doing that over and more and more and more, your farm would be the farm um that has the sweetest watermelons or grapes because you over the years just been selecting the ones that was the sweetest, and then the ones that's not so sweet, you ignore them. Right. All right. Um, I need to send the invite to the class to the rest of the peoples because we
Is that the last question for it?
that's the last question.
They starting matter of Ivy.
We start master 5.
Mm.
We haven't even gone to the real stuff, man. The section B.
Yeah, this is but then if we start this now, you won't be able to finish it, right?
We won't be able to finish.
Makes sense.
So do 5 homework.
Five. I don't know how to screenshot on this desktop. So what paper is this?
This is 20. You can't screenshot in the desktop.
That's
Press
2013 paper 3.
Um,
2013 paper 3. Questions 3 and 5.
paper 3K. So we have two types of homework. We have section D, question 5, and then we also have question number 3 from section 3.
Yes, ma'am.
Okay.
From section 1. Or
Okay.
section A rather. Section A.
Question 5. Okay, I'll send you the homework because I have free time and I like homework. You know, homework is really fun. I also don't like the homework. Homework is teach me on my own stuff I didn't even know.
Yes.
I share the opposite sentiment.
It's okay, ain't for everyone. Who in the
Yeah,
back?
I never in my life. So
No, the only homework I hate is the English homework. But every other homework, I like it because it rocks the brain. That's when you know you're working.
Yeah, yeah.
Yeah, I picked it up from Mr. Petit. He made me do something, and then ever since I noticed that it actually works, I pick up that line he says. It rocks the brain. That's when you know you're working.
Yeah.
So,
If it's easy,
It
then yeah.
rocks the brain.
yes, it's taxing.
Yeah.
I get confused, get a headache, gotta come back, do it again, get a headache, go sleep, get up, and do it again.
That's when you know you're working. That's
Oh,
when.
Bethel, you're invited for the South if you really want it, because we're having South today. So if you want to come down, I don't know if you like vegetables and stuff, but you're free to come.
Sure.
Mr. Petit, I can't invite you. You like it's meat, so I can't.
I love to let Miss Petite escort me there.
No, I gotta keep Mr. Petit okay. I gotta keep him on the right path because I can't invite him and then he see chicken and he want chicken. No, 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 no. I gotta help him stay on this vegan diet.
Amen.
Yes. Sorry, but I'm not a part of it. But you, sorry.
So what time y'all kitchen close?
Well, that's a great question. When she said dinner is ready, I am out. We'll be out by the time she said dinner ready because I once I grab my three, I just grab it like this. I just grab three sections of food: one for the day, one for the mom, one for late night snack, one for. I section it off basically. So by the time as I get, there's nothing left. But you could still come see if you carry the pot. I don't know.
Yeah, the bones for my dogs. That could work too.
Yeah. When I get old, I think I'm gonna try to be a pescatarian because then I go feel like I lose this thing. So do we stay on until 5?
Yeah. Only 5 minutes now.
I thought you had to eat.
Ain't ready yet. Y'all relax. Ain't ready yet. When I'm ready, when you call my name, that's when you know I gone. I'm only messing, guys. Class is more important.
What type of tea did she bring for you, Nancy?
The type of what?
What type of tea?
How you know I had tea?
I want to know.
Anyway, it was lemon ginger tea. Yeah. I don't like
Three
ginger
avocado, one oatmeal.
broccoli. What happened to all them people that was in the class prior to this? Like we had so much people in the class. Now it's very few.
Only the strongest survive. Hey, Mario. Yeah, we waiting on you. Okay, cool.
Whatever happened to that Jeremiah guy?
You all wanted to get hot, right? All this rain, I expected it to be cold. And I gotta shake myself because the fan in.
Turn on the AC then.
No, you can make noise this time to time.
You want with that?
It's just one and you sure, right?
Good day, good day.
Hey, avocado.
Good day.
What's up with you? What are we doing today?
Say,
Any people? I said, what are we doing today?
just paper threes.
Oh, paper trees, all right.
Yeah. Oh, and then Mr. Forbes. So what y'all do for your mother today?
No comment.
No comment. No comment.
See Miss Yadi turn off
What's
her
up with you?
mic.
Yes, sir. Yes, sir.
Uh, can I send you some questions like from the paper tree? Like to do?
Yeah. I want you to send me because I don't have that paper. Send me the thing. I don't have the 2021. You hear me, Mr. Mario?
Yeah, yeah, you.
Yeah, send me that paper so we can do that as well.
Oh, I was asked if you could do the community frequency bottom thingy. But will that come back? Cause it just came last year, man.
Say it again.
Will that come this year? The cumulative frequency.
We don't know. You can't. I can't say. I can't say
Cause
if it will or will not. I can't make that claim. It's on the syllabus and it has come multiple times before.
okay, and we're going from 5 to 9 today or 5 to 8.
I said 5 to 9, Nancy. I did not say 5 to 8.
Oh, why, Nancy, you worrying though?
And you know
You
that.
say she was going anyway.
And you know
When they
that.
call her